This is property of limits with a rational function, okay? So again, we're looking at our limit rules. We'll bring that up actually. Move the limit rule over there. There we go. So we look at our limit rules. Oh, this is not the question. There it is. There we go. Sorry about that. Okay, so properties of limits. We have our question here. Again, this one's going to encompass quite a few rules. We'll just briefly bring them up. We have an exponent. We have a constant. We have a coefficient. So right there, those are the same rules we had before. Rule 1, Rule 4, Rule 7. We also are going to be dealing with a division rule here. So that's going to be our Rule 6. So essentially what we can find is the limit of the top function, and then just divide that number by the limit of the bottom function. Okay? So we're not going to split this up into all those limits again. This time we're just going to do some strict substitution into it, kind of like what we did at the end of the last time we did this. So what this essentially becomes is we can find just the limit of x as it approaches negative 1 with our function x squared minus 5x plus 2, and that entire limit is going to be divided by the limit of x as it approaches negative 1 with the function 2x cubed plus 3x plus 1. Okay. Now, as we showed at the end of the last question, this could kind of really go into strict substitution for our values of x. So when we go to and we found our limits, x approaches 1, we become negative 1 squared minus 5, negative 1 plus 2, all divided by 2 negative 1 cubed plus 3 negative 1 plus 1. Okay. We work this out. This becomes 1 plus 5 plus 2 divided by negative 2 minus 3 plus 1. This becomes 7, 8. Negative 5 plus 1, negative 4, which is the same as the number negative 2. So, what we've just found out is the limit of x as it approaches negative 1 in this function is the number negative 2. Okay? We're going to keep moving.